In this video, let me solve one numerical on Z transform. Find the Z transform of the signal. Here the discrete signal x of n is given. We are supposed to find the Z transform of that. So here we can see that x of n consists of two different signals. The first signal is this one. I will call this as say x1 of n, and I will call this signal as say y1 of n. So here x1 of n convolution with y1 of n, we are supposed to find the Z transform of this convolution of signals. We know that convolution of signals in time domain is equal to product of the signals in Z domain. So let me consider the first signal, that is x1 of n. That is, I can say x1 of n is equal to n minus 0.5 power n u of n. So here let me consider this signal as x2 of n, because we know that n x2 of n, its Z transform will be minus z d by dz x2 of z. So here we have x2 of z. x2 of z is Z transform of x2 of n. So first let me calculate the Z transform of x2 of n, where x2 of n is minus 0.5 power n u of n. So here let me solve x2 of n. That is, x2 of n is equal to minus 0.5 power n u of n. So Z transform of this will be x2 of z is equal to summation n is equal to minus infinity to infinity minus 0.5 power n u of n z power minus n. So here we have u of n. It means that it is right sided sequence. It means that for n less than 0 the signal is 0. Therefore here the limit varies from n is equal to 0 to infinity minus 0.5 power n z power minus n. Simplifying this further, I can write n is equal to 0 to infinity. I'll take n as common, minus 0.5 z inverse power n. We know that summation n is equal to 0 to infinity alpha power n is nothing but 1 upon 1 minus alpha. So here comparing this with alpha, alpha value is minus 0.5 z inverse. Therefore I can write x2 of z is equal to 1 upon 1 minus alpha. Alpha means minus 0.5 z inverse, or I can write x2 of z is equal to 1 upon 1 plus 0.5 z inverse. So here we can see that the ROC is z greater than 1 by 2. So this can be represented as 1 upon 1 plus 0.5 divided by z, or I can write x2 of z is equal to z divided by z plus 0.5. So here this is the Z transform of sequence x2 of n. So now in this equation we have differentiation of x2 of z with respect to z, and multiplying with minus z will get the Z transform of x1 of n sequence. Now let me differentiate this x2 of z sequence. That is, differentiate x2 of z with respect to z. Therefore d by dz x2 of z is equal to, so here we have z divided by z plus 0.5. Keep denominator as it is, that is z plus 0.5 Differentiation of numerator is 1 minus, keep numerator as it is. Differentiation of denominator is, here we have differentiation of z is 1, constant is 0. That is 1 divided by, we have z plus 0.5 square. So simplifying this, I can write z plus 0.5 minus z divided by z plus 0.5 square, or it is equal to 0.5 divided by z plus 0.5 square. So y1 of n is equal to 4 power n u of minus n. y1 of n is equal to 4 power n u of minus n. We'll take z transform of this, that is y1 of z is equal to summation n is equal to minus infinity to infinity 4 power n u of minus n z power minus n. Simplifying this, I can write, so here we have u of minus n indicates it is left side signals, that is n greater than 0, the signal is 0. It means that the summation n varies from minus infinity to 0. For n greater than 0, the signal will be 0. 4 power n z power minus n, or I can represent it as summation n is equal to minus infinity to 0 4 z inverse power n. So for simplification purpose, I will try to bring this to standard form. Let m is equal to minus n. So if we consider minus n as m, in that case this n will become minus m. So minus m is equal to minus infinity means m is equal to plus infinity. Therefore I can write it as summation m is equal to infinity to 0. We have 4 z inverse. Here n should be replaced by minus m, or this I can represent it as summation m is equal to 0 to infinity. We have 4 power minus m z power m, or I can write y1 of z is equal to summation m is equal to 0 to infinity 4 inverse z power m. So therefore I can write y1 of z is equal to, it is of form alpha power m, that is 1 upon 1 minus alpha, that is 1 upon 1 minus alpha means 4 inverse z. 4 inverse means 1 upon 4, that is 1 by 4 z. Here the ROC will be, z will be less than 4. So simplifying this, I can get y1 of z is equal to 4 divided by 4 minus z. I will call it as equation number 2. So now we know that x1 of n star y1 of n, its z transform will be x1 of z dot y1 of z. That it will become the convolution in time domain is equal to product in z domain. Therefore we can write x1 of z dot y1 of z is nothing but x of z. Therefore x of z is equal to x1 of z is minus 0.5 z divided by z plus 0.5 square minus 0.5 z divided by z plus 0.5 square into, we have 4 divided by 4 minus z. Or simplifying this, I can write x of z is equal to minus 0.5 into 4 is minus 2z divided by z plus 0.5 square 4 minus z. So this is the Z transform of given signal. Let me solve this problem using another method, that is directly by using Z transform properties. Alternate method. So here the given signal is x of n is equal to n minus 0.5 power n u of n star, we have 4 power n u of minus n. Let me solve this using directly the Z transform properties. That is, we know that alpha power n u of n, the Z transform of this is given by Z divided by Z minus alpha. So here we can see that minus 0.5 raised to n u of n is nothing but here alpha value is minus 0.5. Therefore, minus 0.5 power n u of n, its Z transform will be Z divided by Z minus alpha, that is Z plus 0.5. Also we know that the Z transform of n alpha power n u of n is given by, that is Z transform of this will be minus Z d by dz, that is differentiation of x of z. So therefore, say this is x1 of n and this is y1 of n. Therefore, x1 of z will be, already we have found the differentiation of x of z, that is differentiation of this signal with respect to z, that is minus z. So the value is already done, that is 0.5 divided by z plus 0.5 square. 0.5 z divided by z plus 0.5, z plus 0.5 square. So similarly, say this is first equation which is same as previous one. Now applying the same rule, we know that the Z transform of alpha power n u of n is Z divided by Z minus alpha. So now alpha power n u of n, that is u of minus n, it will be 1 over z divided by 1 over z minus alpha. 1 by z minus 1 by alpha. So therefore here we have 4 power n u of minus n, its z transform will be 1 over z divided by 1 over z minus 1 by 4. So simplifying this, we can get, so here the 4z will be the LCM, 4z divided by z, and here on denominator we have 4 minus z, that is, which is equal to 4 divided by 4 minus z. This is equation number 2. So now by taking the product of 1 and 2, we'll get the same expression, that is this one, that is x of z. Thank you for watching.